Our topic for right now is going to be on proportions. And the whole big definition is that a proportion is where a ratio is set equal to another ratio, or in the case of a rate, remember that's where the units differ, a rate is equal to a rate. And we're going to show this with your favorite guy, the fraction. How we can have a fraction set equal to a fraction. Now, once you set it equal, now what do you do with it? Well, one little mathematical fact pops out. That if you were to take A times D and then B times C, which is what they call the cross product, those cross products are equal. So again, for those to be equal, it's like taking the numerator of the one times the denominator of the other, getting a generic number, and it has to equal the same value you get when you multiply the other two numbers. Now, what we do with that is really the key. But first, let's do a little more background. Let's check to see if a proportion is really true or false. We'll put in some definite numbers. Here we have 5/8 equals 10/16. Sounds good, but is that really a true statement? How we can check? Cross multiplication. So we're going to take 8 times 10 and get an 80. Store that number. You take the other product, which is 5 times 16. Ooh, look at that, 80. So we have a winner. Yes, indeed, that is a proportion. Over here, we have 4/5 equals 8/9. Again, question mark, we're not quite sure if that is a true statement. When we cross multiply here, we get 8 times 5, which is 40. And then in the other direction, we would get 4 times 9, which would be 36. That's a big old no. Those cross products did not equal each other, so that is not a true proportion. Those two are not equal to each other. Now, let's actually take another step with that information and actually try to solve a proportion. Notice to solve means there's something missing, unknown, a gap. And we have 60 is to W, whatever W is, and 24 is to 7. Those are set equal to each other. So we have to find that missing piece. So let's take a look. When we cross multiply, 60 times 7 is 420. And again, it doesn't make a difference right or left because the equation decides it doesn't make a difference, it's reflexive. So you take 24 times W and you get 24W. Most people would probably put the variable on the left. It's not a big deal breaker, but it's just sort of out of habit. So you can do that multiplication, put that on the left. But again, left or right doesn't make a difference. Now, you got 24W equals 420. Nice mathematical sentence, but you don't want 24 of those W's, you want just one. So you're going to divide by 24, again to keep the balance, got to do it on both sides. So when you number crunch, 420 divided by 24 is going to be 17.5. And again, in your head, you're always thinking that cross multiplication. You don't necessarily even always have to think it in your head at the beginning. If you want to make sure, you can lightly put those arrows right over it, or the circles, anything to remind yourself what is getting multiplied together. Let's do another one just to make certain. Here's a nice proportion that we want to solve. 15 over 20 is the same as 12 over n. Notice how it doesn't really make a difference what variable you choose or if it's top or bottom, left or right. Just the fact if you have 3 pieces that you know and 1 that you don't. When you cross multiply, you're going to get 15 times n, 15n. Multiplying the other two numbers, you get 20 times 12, which is 240. Again, you're one step away from solution, and that is to divide both sides by 15. When you number crunch here, hopefully you do it correctly. Always check again. But you 240 divided by 15 is 16. So that would mean that 15 over 20 is the same as 12 over 16. Sounds curiously a lot like what we did back when we were talking about fractions and having to go and make equivalent fractions and build up fractions with a specific denominator. And basically, we're using those same skills. Sorry to disappoint you. All right, nothing totally new. What might be new being able to apply this knowledge. And that is really where things get cooking. The fact of having the skill very sort of generic and being able to crank it out is one thing, but you want to take it up a notch and being able to do something with it. So here we go. We have a little scenario here that when you're 50 pounds, it takes a 2-ounce tablet for your medication. But now you're 175 pounds. How much medication should you take? Well, proportion. Notice how we have one complete thought. 50 pounds, 2-ounce tablet. All right, so we have our medicine to the tablet. We could have done it the other way. It's a free country. You just have to be consistent. I just did the medicine to the pounds. So over here, I have to have medicine to the pounds. Right? So again, once you set it up, you're right back to the last two examples that we had talked about. We're going to cross multiply. And again, once you cross multiply, one step away. Just divide, in this case, by that coefficient, that number in front of that variable, and you, in this case, we get 7. Don't forget about the units. Very, very important. Makes a difference whether it's 7 ounces, 7 cups. So really got to be on any applied problem. Be really very vigilant. Make sure to label your answers. Again, let's do one more. Lots of different situations. Use proportions. Here's another one. We have 3 tablespoons of plant food is needed for 4 gallons of water. See, a fact. Now we're either going to extend that and feed a whole army of plants, or shrink it down and maybe just deal with 1. For our purposes here, we have 10 gallons of water. Okay. Again, we have part of our extension, but we need the other part, and that's how many tablespoons of plant food. As we go through, you always have to take that one fact that you're given. 3 tablespoons of food to 4 gallons of water. See, food to water, so we have to have food to water over there. You got to keep that same relationship. If you're finding yourself getting them backwards, actually write in the units, or write a little note to yourself. Food to water, so that you can, at the beginning, keep things straight. Again, cross multiplication. 4 times x equals 3 times 10. Remember, we're one step away from solving. Divide, in this case, by 4. And we end up with 7.5, and remember, tablespoons. Always remember to label. Now, one thing we didn't really do an example per se here, but we could talk about it. Everything sort of worked out nice. We maybe got a decimal or fraction. But we could have all of these numbers, could be fractions, could be decimals. We just use nice whole numbers for illustration purposes. But remember, real life is not that nice. So be on the lookout if you do hit a problem with fractions or decimals. You handle it the same way, all right? Remember, cross multiplication, you can do it.